In this part, I want to talk about the logarithmic function. So before we introduce the logarithmic function, let's look at the function which is called a one-to-one function. One-to-one function. Sometimes we just write one-to-one. Okay. Okay, so what is the one-to-one function? Let's look at the following graph. This is a one-to-one function. Why? It's that you see for each y values on its range, they're corresponding to only one x values. Right? So this is not a one-to-one function, for example. Because if we have this y values, you see, if you draw a horizontal line, so that means it intersects this curve at 2 points. So this y values corresponds to two x values. So if we say a function is f function is one-to-one if for each y value corresponds to only one x value. Of course, this y value should be in its range. Okay, so then this is called the one-to-one function. So from the graph that we also have, it gives you an idea how to identify a function is a one-to-one function. We just needed to draw a horizontal line, right? The horizontal line. So if the horizontal line intersects the graph only at one point, for arbitrary horizontal line, intersects the graph at most one point, then we see this function is one-to-one function. If there is certain horizontal function, a horizontal line intersects the graph at more than 1 point, for example 2 points or 3 points, then that function is not a one-to-one function. So this is called the horizontal line test. Okay, do you remember we have learned the vertical line test? The vertical line test is used to identify a curve is a function or not, right? The horizontal line test is to identify this function is a one-to-one function or not. Okay. So why we want to introduce a one-to-one function? The reason is there is some facts that if a function is f is one-to-one, then f has an inverse function. F has an inverse function. So the next question is, what is, okay, if a function is not one-to-one, if f is not one-to-one, then the inverse function does not exist. So the question is, what is an inverse function? The inverse function says, the inverse function is if a point xy is on the graph of a function f, then yx is on the graph of its inverse function, its inverse. So in other words, how to identify, how to find a function, the inverse function is formed by the inverse function of f is formed by swapping xy. Okay, swapping xy. So this is called the inverse function. So why we want to introduce an inverse function? Okay, so this is another thing I want to talk about is, so since we just interchanged x and y, so that means if this is the curve of the function y equals fx, then if this is the point AB point, then we know that BA point would be on its inverse function. So if this is AB, then this is BA. Okay? Then for each point, if this is the CD, then this would be the DC. Right? So you will get another curve, which is the curve of its inverse. Okay? So this is curve, so this is AB, so this is BA. And here is CD, and this would be the DC. Okay, so you can see that these two curves are symmetric with respect to the line y equals x line. If you connect these 2 points, this is the line perpendicular to the y equals x line. If you connect these 2 points are also, the line is also perpendicular to the x equals y line. So these two curves are symmetric. So the graph of the inverse functions are symmetric to the line y equals x. Okay, so why we want to learn the inverse function? The reason is, if you we have the exponential, we have learned the exponential function y equals b to the x, right? By y equals b to the x. So we know that b to the x, no matter what b is, right? B is greater than 0, not equal to 1. No matter what b is in this range, the graph will look like this one, or this one, right? Or this one. So you can see that if you draw a horizontal line, it only intersects the curve at one point. So this function, this exponential function is one-to-one function, right? So it must have its inverse function. So what is the inverse function? The inverse function y equals b to the x is just swap, just to swap x and y, okay? So it becomes x equals b to the y. So this one is the inverse function of y equals b to the x. So, but in general, we always like to write as y equals something, right? Can we write this one as y equals something? We have no idea, right? We don't know how to do that. So, the mathematician introduced a new function which is called the logarithmic function. They want to write y as y is, they say, okay, if x equals b to the y, that means y equals log to the base b of x. So in other words, these two are equivalent. Okay, x equals b to the x. It means y equals log of base b of x. Okay, so this is called the exponential form, and this is called the logarithmic form. So this is called the logarithmic function because this is the function of, this is called the logarithmic function. This is called the logarithmic function. Okay, so now let's look at the domain. The domain is, so this x is the x here, right? And this is b to the y. B to the y is always non-negative, right? So this one, x is always greater than 0. So in other words, the domain of the logarithmic function y equals log b of x, the domain is x greater than 0. This is the domain. Let's look at the range. The range could be any real numbers because this y is the same y as here, and you can plug in any y you want, right? So the range is y from negative infinity to positive infinity. Okay. So this is the range. So what about the graph? The graph is also, we also have two different cases, right? Because it's based on the b. If b is greater than 1, then the graph is an increasing graph, an increasing function. The vertical line, the vertical asymptote is y-axis, okay? And it must go through the point, we know the exponential function must go through the point 0, 1 point. So the logarithmic function must go through the point 1, 0, 1 point. 1, 0 point, sorry. 1, 0 point. So from the graph, you can see this x value. So this is for the log y equals log to the base b of x. So you can see this is the x values, right, domain and the range. The y values can be any number, right, can be any number you want. But for the x here is always on the positive x-axis, right? The same thing for the b greater than 0, less than 1. So the graph will look like this one. Still use the y-axis as its vertical asymptote, but it still goes through the point 1 point, but the function is a decreasing function. Okay, the function is a decreasing function. So now we want to look at some examples. The one example is we want to convert to a logarithmic equation. Okay. 3 to the 4th equals 81. We want to convert this one as a logarithmic equation or logarithmic form. So that means we know that x equals b to the y is equivalent to y equals log to the base b of x, right? So here y is 4, x is 81. So that means 4 is equal to the log to the base 3 of 81. This is the logarithmic form. Another one is 7 to the negative 2, which is 1 over 49. So that means we still use this relation. You can see that the negative 2 is equal to the log to the base 7 of 1 over 49. So if you have a to the b equals c, then we can say that the equivalent logarithmic form is b equals log to the base a of c. Okay, so we can also use the backward. We can convert the logarithmic function equation form to the exponential form. For example, if you have log to the base 2 over 16 equals 4. So that means, so right here, this is x equals b to the y. It's equivalent to say that y equals log of b to the base b of x. Okay? So here, x is 16. And b is 2 and y is 4, right? So it's 16 equals 2 to the 4th. So 2 is always will be the base, no matter it's in the logarithmic form or in the exponential form, right? There. Another one is the log 8 of 2 equals 1/3. So that means 2 equals 8 to the 1/3. Yes. Okay. If you have a more general case, log to the base q of p equals w. So that means p is equal to q to the w. Okay. So if we want to use this way to solve some result, some equations about the logarithmic function, so we have log, we will talk this one later. So now let's look at some properties of the logarithmic function.